The other thing is radiation. Radiation, like first one was conduction, and the second one was convection, and this one is radiation. So radiation is an energy transfer process in which heat flows through space by means of electromagnetic waves. Radiation transfer also is like there are waves that come from the sun, so we call them electromagnetic waves. So radiative heat transfer occurs when the emitted radiation strikes another body, when it strikes another body, and when it is absorbed by this, we call this radiative heat transfer. We all experience radiative heat transfer every day. Solar radiation, observed by our skin, is why we feel warmer in the sun, in the shadow. And solar water heaters, solar cookers, microwave ovens, you can take baths are a few examples in which radiation is utilized for producing it. So you can take this. Solar water heater, solar cooker, and microwave ovens are the best examples of radiation way of mode of heat transfer. So you can look here, it travels to food in ways in the same way that it travels in the earth from the sunlight, as you can see here. So radiation occurs when food is grilled. When you grill a food in the bath, what's really happening is radiation. The food does not touch the grill, but the heat cooks the food. This is the point. It doesn't touch the grill, but the heat really cooks the food. We call this thing radiation. Which is like, we are coming the same slide here, which is the third method of transfer. We were talking about that, radiation. How does heat energy get from the sun to earth? We have sun and we have earth. It's obvious through radiation. There are no particles between the sun and the earth, so it cannot travel by conduction or convection. As long as there is no particle between the sun and the earth, we can say we can get the energy from the sun through convection or conduction. So the answer is radiation. The heat energy that we get from the sun to the earth is through radiation. So radiation travels in straight lines, yes. Radiation requires particles to travel, no. Radiation travels at the speed of light, yes. These are the things which are quite interesting to have in your mind. So the transfer of energy by we have said this before, by electromagnetic waves. Such of examples are sun, fire, and light bulb. So overall, we can have this one is like, this thing that we are experiencing are radiation, and here we have conduction between two solid particles, but here we have convection, which is from the solid part to the water. So we can have this good overview by just looking at this thing, which is quite simple. So let's now talk about modes of feed heat transfer. Heat transfer by convection is involved between two fluids. This is involved between two fluids by convection. The first one is parallel heat flow, and the second one is countercurrent flow, which will experience between two fluids. So if you see in parallel heat flow, there is variation in temperature, and the same thing if you see here countercurrent heat flow, there is also the temperature gradient here. So if we see parallel heat flow, when the hot fluid and the cold fluid enter the apparatus from the same end, like they enter the apparatus from the same end, the flow is parallel, and the flow is like parallel. They enter in the same direction, and the same thing is happening, which is the flow is parallel to each other. This arrangement is known as parallel flow. So the apparatus of the hot fluid inside a pipe decreases from T1 to T2. We will see this one on the next image. Like as you see, we have the temperature, we have the distance. So those two fluids are entering from here, hot fluid here, cold fluid here. So we call this parallel flow. We call it parallel flow because they are entering from the same side. At the same time, they are moving in a parallel way. Or simply, we don't have hot fluid in, we don't have cold fluid in, and then we don't have cold fluid out and hot fluid out. So when they move through this way, their movement is what? In parallel form. At the same time, they are entering from the same side, and they're also their outside is also in the same side. So we call this parallel heat flow. The other thing is countercurrent heat flow, which is we call temperature gradient. Here, when hot fluid is passes through one end of the apparatus, while cold fluid is passes through the other end, like they don't have opposite end. So fluid pass in opposite direction. This arrangement is known as counter current or counter flow. So we will see as a figure, this is simply easy. You can read this text if you want to. This one, like as you can see, the hot fluid is coming right here, the cold fluid is coming right here. So we call this counter currented flow. These are like broad concept. What I am trying here is I am trying to give you an introduction. I couldn't say this is a complete course, but it's like a kind of introduction. So I just want you to dive in and learn these things, like try to go beyond the limit, okay? If you are really passionate about this area. And let's see here, thermal radiation usually occurs simultaneously with, we don't have thermal radiation, we were talking about that thing, and simultaneously with heat transfer by convection and conduction. One of the advantages is the radiation source corresponding to wavelengths from 0.8 to 400 micrometer is for thermal radiation, and the other thing is radiant energy penetrates a short distance, 1 to 2 micrometer into material, which are good properties of the thermal radiation to have in our energy sources.